The last class we are discussing about that alkyl halides and aryl halides is nothing but halogen compounds. Level 1 bits, some bits we are discussed. Let's see the remaining bits. Level 1 is very easy and level 2 also very easy, just a little bit difficulty is there. Okay, students. So the thing is concepts, and we have to practice that equations and molecular formulas and reaction mechanisms. So first PUC organic chemistry is very important for solving the total second PUC organic chemistry. For understanding second PUC organic chemistry, we must have to revise more and more times first PUC organic chemistry. Okay, let's see that 21 question. It's very easy. The related to SN2 mechanism. See SN1 reaction orders. Different alkyl halides are present. The R group is different. Different alkyl halides are present. In that case, SN1 reactivity order. We know very well tertiary alkyl halides are more reactive than secondary alkyl halides and then primary alkyl halides. It is exactly reverse for the SN1 mechanism. So among that, methyl chloride is primary. Ethyl chloride is also primary alkyl halide because the halogen is attached to one carbon. The attached carbon is primary carbon. That alkyl halides are called primary alkyl halides. So it is 1-chloropropane is also primary alkyl halide. This is tertiary butyl chloride. This is tertiary carbon. So the tertiary carbon is halogen is attached to tertiary carbon. That alkyl halide mostly prefers in SN1 mechanism. So the answer is 4. Let's see that 22 question. Chlorine and carbon bond in chlorobenzene. Chlorobenzene structure we know very well. Okay, yes students. And that chlorine and carbon bond in methyl chloride. Methyl chloride means CH3 bond Cl. C. Then what it is? Among that, which statement is correct related for this carbon and chlorine bond in chlorobenzene and methyl chloride? If you are observed that in aryl halides, this is nothing but chlorobenzene is nothing but aryl halides or aryl chloride. It is nothing but alkyl chloride, alkyl halide or alkyl chloride. Okay. See, this halogen attached carbon is sp2 carbon, and here halogen attached carbon is sp3 carbon. Okay. Now the electronegativity of carbons, sp carbon electronegativity is more when compared to sp2 carbon than sp3 carbon. So sp carbon electronegativity is more means the bond length is more for sp3 carbon. sp3 carbon attached groups having more bond length when compared to sp2 carbon, and then sp carbon bond length. Automatically, what about the strength? Bond energy or bond strength? The bond strength is more for sp and then sp2 and then sp3. Now in aryl halides, carbon and chlorine, in aryl halides, aryl chloride, carbon and chlorine bond length is less. Bond length is less or shorter bond length. Bond length is less and bond energy is more. Bond energy is more than methyl chloride. Methyl chloride in carbon and chlorine bond. Carbon and chlorine bond. Understood? So the answer is in carbon chlorine bond in chlorobenzene is shorter bond length, and but it is stronger. It is stronger. Okay. So the answer is third option is correct. Okay. Let's go for 23. See, just it is the IUPAC nomenclature. The benzene ring having 2 halogen atoms present at adjacent 1-2 position, it is called commonly ortho position. Now its IUPAC name do you want means what is the portion of chlorine halogen atoms? 1 and 2. 1 and 2 means its IUPAC name is the substance. Halogens are substance. That's why substance name first. Then the root word and its nature. Okay. Now its IUPAC name is 1, 2 dichloro benzene. Dichlorobenzene is the correct name. 1, 2 dichloro. 2 chlorines are. That's why dichloro. So the first option is correct. Okay, students. Let's go for 24th question. Okay. Let's see 24th. In aryl halides. In aryl halides, carbon atom holding halogen is already just now only we have discussed. Aryl halides means what? The halogen is directly attached to the benzene ring. Halogen is directly attached to the benzene ring. Those are called as aryl halides. Okay, aryl halides. Now that aryl halides halogen attached carbon hybridization is what? sp2 carbon. sp2 carbon. So that's hybridization of that carbon is sp2 hybridization. Now let's see the 25th question. The following aryl alkyl halide means aryl alkyl halide. Aryl alkyl halide means the organic compound has benzene ring. So the organic compound OC means organic compound has benzene ring and halogen is attached to alkyl group. The type of compounds are called aryl alkyl halides. Let's see that among that which is aryl alkyl halides. The first option is orthochlorotoluene. Toluene means we know very well the benzene ring having CH3 group is known as toluene. At our second portion, chlorine is present, it is called orthotoluene. It is the halogen is directly attached to the benzene ring. So it is aryl halide only. Is not aryl alkyl halide, not aryl alkyl halide. This is just only aryl halide. Means aromatic halogen compounds. Ortho-bromo-chlorobenzene means the benzene ring having 1 and 2 positions, chlorine and bromine is present. It is also aryl chloride or aryl halide. Aryl dihalide. Now the third one is 1-chloro 2-phenyl ethane. Ethane means 2 carbon atoms. Okay, on the 2 carbon atoms, the first carbon, this is 1 and 2. The second carbon having benzene ring. Okay, and first carbon having chlorine, the remaining valence is satisfied by hydrogen atoms. 2 bonds are present, then it is CH2, and here also CH2 will comes. Now what is this compound here? If you observe that the halogen is attached to alkyl group, and this is a aryl group. So this compound is aryl alkyl halide. That is aryl alkyl halide. So the answer is third option is correct. Next, see the toluene. Toluene is nothing but it is methyl benzene is called toluene. Okay, so is not a halogen compound. So the answer is third option. Okay, let's go for next question. 26. 26th question. The chlorobenzene can be prepared. Chlorobenzene. Among the following, which reagent is useful for the preparation of chlorobenzene from benzene? So, while the preparation of aryl halides, there only we have discussed the benzene is converted into chlorobenzene. Among that, which is your, sorry, chlorobenzene can be prepared from benzene diazonium chloride. Sorry. Benzene diazonium chloride means the benzene ring having N2Cl group, N2 plus Cl minus is converted into chlorobenzene. It is nothing but what the reaction, dear students? Sandmeyer reaction. Sandmeyer reaction already we are studied. So the Sandmeyer reaction, what are the reagent we are using for the preparation of chlorobenzene? Cuprous chloride, Cu2Cl2 by HCl on heating. Then we are getting chlorobenzene. The byproduct is N2. Here, because generally aryl halides does not undergoes nucleophilic substitution reactions, but the benzene diazonium salts N2Cl is strong electron withdrawing group, minus I group, then it generates the positive charge on benzene ring. It generates the electron deficiency on benzene ring. It generates the electron deficiency on a benzene ring. Okay, that's why. Okay, that's why this reaction, benzene diazonium chloride, is very important intermediate for the synthesis of aryl halides. Chlorobenzene, bromobenzene, iodobenzene, we can prepare. So among that benzene diazonium salt is converted into chlorobenzene. Either cuprous chloride, HCl we are used, it is called Sandmeyer reaction. Copper powder, HCl if you are used, it is Gatterman-Koch reaction. Gatterman reaction. Gatterman reaction. Okay. So then also the product is chlorobenzene will form. So here copper powder and HCl not give. So CuCl2 HCl is the suitable reagent for the synthesis of chlorobenzene from benzene diazonium chloride. Okay. Let's go for next question. 27. Very easy. So benzene reacts with chlorine in the presence of FeCl3. In the presence of FeCl3, what is the product? See, this is nothing but electrophilic substitution reaction of benzene. In first piece only we are studied electrophilic substitution reactions of benzene. In that one important electrophilic substitution is halogenation of benzene. Halogenation reactions. Halogenation reaction. Okay. So the benzene reacts with chlorine or bromine, but iodination is not possible. Direct iodination is not possible. So do you want iodination or preparation of iodobenzene? In the presence of oxidizing agent is required. FeCl3 is Lewis catalyst or AlCl3. So then the electrophile is here Cl plus. Then converted into chlorobenzene. So this reaction, what is the product? So the first one is correct. Chlorobenzene will forms. Okay, students. So benzene halogenation reaction. Halogenation of benzene, nitration, sulfonation of benzene. These all are electrophilic substitution reactions, and we know very well aromatic compounds like benzene and benzene derivatives, mostly they involve in electrophilic substitution reactions because the benzene has more electron rich group. So where the electron density is more, then the electrophile will be attacked on electron density species only. That's why aromatic compounds mostly involved in electrophilic substitution reactions. Okay, let's go for next question. Let's see among the following which is Sandmeyer reaction they are asked. Which is an example for Sandmeyer reaction? CuCl, HCl. So this is a Sandmeyer reaction. So this is also just benzene diazonium salt and hydrolysis we are getting phenol. And benzene diazonium chloride is treated with HbF4 to produce fluorobenzene. What is this reaction? This reaction name is Boltzmann reaction. Boltzmann reaction is this actually directly from benzene diazonium chloride directly we can't prepare fluorobenzene. So that benzene diazonium chloride first we have to treat it with HbF4. Then what will the product will forms? Benzene C6H5 N2BF4 will forms. N2 plus BF4 minus. N2BF4 is on heating to produce fluorobenzene plus BF3 plus N2 will forms. Okay. So this reaction is known as Boltzmann reactions. Among that, Sandmeyer reaction is first one. Okay. Let's see that 29th question. The chlorobenzene treated with CH3Cl in the presence of AlCl3 means this is reaction is nothing but Friedel-Crafts alkylation reaction. Alkylation reaction. Okay, students. See the chlorobenzene. Cl group is ortho and para directing group. It is ortho and para directing groups because it increases the electron density at ortho and para positions. Ortho and para directing group. Directing group. So when the incoming electrophile will be attacked at ortho and para positions. So this is reacts with CH3Cl, methyl chloride or chloromethane. In the presence of AlCl3, the electrophile is CH3 plus. This CH3 plus will be attacked at ortho and para positions. Orthomethyl chlorobenzene and paramethyl chlorobenzene or orthochlorotoluene and parachlorotoluene will forms. Because the benzene ring having CH3, then it is a derivative of toluene. So at that place, chlorine becomes a substance. Now it is orthochlorotoluene and this is parachlorotoluene. Okay, students. So the answer is the mixture of ortho and parachlorotoluene is the product. Okay. Let's go for next question. (29) completed. 30th question. Let's see. Direct. 30th question. C6H5Cl. What is the product? Two chlorobenzenes, how many moles? 2 moles. Reacts with 2 moles of sodium metal in the presence of dry ether. Dry ether is a solvent. Then the loss of NaCl. Loss of NaCl. The product is what is the name? Biphenyl. Biphenyl is the product name. 2 phenyl rings are attached through a single bond. And it is one important named reaction also. What is this reaction name? What is this reaction name, dear students? Fittig reaction. This reaction is known as Fittig reaction. And one more important thing. So in the same way, 3 named reactions we are discussed. One is Wurth reaction. The second one is Fittig reaction. Third one is Wurth-Fittig reaction. Third one is Wurth-Fittig reaction. For example, alkyl halides. 2 moles of alkyl halides reacts with sodium metal in the presence of dry ether. What is the product? R bond R plus 2NaX. Means alkanes. Alkane is the product. Okay, this is known as Wurth reaction. This is a Wurth reaction. Now the third one is Wurth-Fittig reaction. Wurth-Fittig reaction. What is Wurth-Fittig reaction? Alkyl halide and aryl halides. Alkyl halide means Rx reacts with sodium metal, and aryl halides in the presence of dry ether forms alkyl benzene. Alkyl benzene. If it is CH3 means what is the product? Toluene will get. So this is known as Wurth-Fittig reaction. So just one only they are asked. Aryl chloride or chlorobenzene, 2 moles of chlorobenzene reacts with sodium metal in the presence of dry ether. What is the product? The product is biphenyl. Sometimes the product only they will give. What is the reaction name? The reaction name is Fittig reaction. Instead of aryl halides, 2 moles of alkyl halide is present, Wurth reaction. One alkyl halide, one aryl halide is present. It is a Wurth-Fittig reaction. And products names also important. Okay, let's go for next question. Chlorobenzene reacts with sodium hydroxide, fused sodium hydroxide. Then the product is phenol. What is the product name? The phenol. And what is the reaction name? That is Dow's process. Already we have discussed that reaction in the preparation methods of phenol. So chlorobenzene you have to take, dear students. Chlorobenzene. Okay. Now this chlorobenzene is treated with sodium hydroxide NaOH on heating. NaOH on heating at around 350 degrees centigrade temperature. 350 degrees centigrade temperature and 300 atmospheric pressure. Then the product is phenol. Product is a phenol. This reaction is known as Dow's process. Dow's process reaction. Let's see 32 question. Chlorobenzene on nitration gives the major product. What is the major product? Ortho and para nitro. Chlorobenzene will get. Among that para product is major. So is nothing but nitration reaction. Nitration reaction of chlorobenzene. Reaction of chlorobenzene. Okay, let's see chlorobenzene. This chlorine is ortho and para directing group. Ortho and para directing group reacts with HNO3. Nitration means HNO3 plus H2SO4 mixture is known as nitrating mixture. Then the electrophile is equals to NO2 plus. Then this NO2 plus attacks at ortho portion as well as para portions. NO2 plus here NO2 will get at para portion. Among that, para product is major product. Para is a major product. So what is this correct IUPAC nomenclature? So its correct IUPAC nomenclature is among that NO2 group is more priority when compared to chlorine. Then the chlorine portion is NO2 portion is we are considered as a substance. Chlorine goes to more priority. Both are substance only, but its correct IUPAC name is according to alphabets. C comes will first when compared to N. That's why it is 1, 2, 3, and 4. So while writing its name, 1-chloro 4-nitrobenzene. 4-nitrobenzene is the major product. Okay, so the answer is first option is correct. Because the chlorine is ortho and para directing group, the electrophile NO2 plus will be attacked at ortho position as well as para positions. Among that, para position is major product. This is ortho. Okay, see here the major and minor they are not asked. Simply the products are mixture of ortho and para nitrochlorobenzene. Like option is present, that is correct. Among that, major they asked means para. Only one, only we have to choose. So among that mixtures, all para is major product. Let's see, already this reaction we discussed. 33. This 33 is what ma? This aryl halide and alkyl halide. This is aryl iodide. This is alkyl iodide, methyl iodide. Methyl iodide. Okay, methyl iodide. So they reacts in the presence of sodium metal and forms toluene. The reaction is Wurtz-Fittig reaction. The reaction is a Wurtz-Fittig reaction. Already we are discussed. Okay, let's go for next questions. Okay, level 1 completed. Next level 2, let's see. Very easy only. This also and important. The first one is isomerization isomerism shown by the 2,3 dichlorobutane. CH3 bond C bond Cl, here H and here chlorine and hydrogen and CH3. It shows what type of isomerism they are asked. Okay, if you are observed that diastereomerism, optical isomerism, geometrical and structural they asked. Now here if you are observed this carbon atom, this chlorine attached carbon atoms, if it is the groups 1, 2, 3 and 4, 1, 2, 3 and 4, 1, 2, 3 and 4. So 4 different groups are present. So it has how many asymmetric centers or chiral carbons are present? 2 asymmetric centers. 2 asymmetric or 2 chiral carbons. Two chiral carbon atoms present, hence it shows optical isomerism. Okay students, optical isomerism. Let's see that second question. The number of possible monochloro structural isomers formed on the monochlorination of isopentane CH3 bond CH bond CH3 bond CH2 CH3. Its molecular formula is C5H12. C5H12. See, this is on monochlorination. Cl2 in the presence of sunlight. Monochlorination. How many possible products will form? 4 products will form. How many monochlorinated products will form? Possible. Among that, which is major, which is minor, they are not asked. So how many possible? So how can we identify? Here we have to identify different types of hydrogen atoms. See, this CH3 and this CH3 contains similar types of hydrogen atoms. Then if you replaced one of the hydrogen atom, if you substituted chlorine, then we'll get only similar type of products. That is A. This is both are A. Now the A is equals to CH3 bond CH bond CH2 Cl bond CH2 bond CH3. This is similar type of product. Now let's say that this B, this carbon atom. This carbon atom hydrogen is present, that hydrogen can be replaced by the chlorine, then it undergoes free radical substitution, then this is B, means it is nothing but free radical substitution reaction. Okay, now the B is equals to CH3 bond CH3, here chlorine will attach. The remaining as it is same. CH2 bond CH3. This is B. Now this is C. At this carbon, secondary carbon it is C, and this is a D product. So total 4 types of product will form. So the C is equals to CH3 CH bond CH3 bond CHCl bond CH3. Okay, let's go for D product. The D product is CH3 bond CH bond CH3 bond CH2 bond CH2Cl. So if you write it there, IUPAC names, all IUPAC names are different, but the molecular formula is same for A, B, C, D. But the arrangements is different, then they belongs to different compounds only. Among that, which is major product? Which is major product? So in the free radical substitution reaction, the stable T, tertiary free radical, more stable than secondary and then primary. So among that, B can produce to tertiary free radical. So the B product is major product among these all. In tertiary alkyl halide is major product, alkyl chloride. But how many possible isomeric monochlorinated isomeric products will form? Structural isomers only. These all are different structural isomers. Means root word is same, but the different substances are present. Different connectivity, bonding connectivity is present. That's why these all are structural isomers. So isopentane on monochlorination, how many structural isomers possible? 4. So the answer is third option. Okay, let's see the third question. Among that isomeric alkanes, the molecular formula C5H12. C5H12. Okay, in that C5H12, which gives 4 isomeric monochlorinated products on photochemical chlorination. Photochemical chlorination is nothing but free radical substitution reaction. So, which gives 4 products, my dear students? Isopentane. This, what is this? CH3 bond CH3 is nothing but isopentane only. At end, any one end, 2 methyl groups attached to 1 carbon, that is called iso group. So that's why 5 carbon atoms containing alkane has 3 chain isomers are present. One is N-pentane, isopentane, neopentane. N-pentane on monochlorination produce 3 products. Isopentane on monochlorination produce 4 products. Neopentane on monochlorination produce 1 product only. Okay. So the answer is 4 products are required, means the answer is isopentane. Let's see. The remaining I'll explain you. N-pentane and neopentane on monochlorination, what type of products it will form. Let's see the first one. N-pentane. N-pentane means CH3, 5 carbon atoms on straight chain. CH3 bond CH2 bond CH2 bond CH2 bond CH3. On chlorination, in the presence of sunlight, produce how many types of products will form? Here, this CH3 and this and at that end CH3 groups, chlorine will be substituted, give same product. Means because the portion of chlorine will be same, either left to right or right to left. And this is B and this is also B and the middle one is C. So how many products? 3 products will form. See, let's see what are the 3 products. A, CH3, CH2, bond CH2, 1, 2, 3, 4, 5, Cl. This is first one. Let's see the B, CH3, bond CH, here at a second carbon, either right to left or left to right, the second carbon position is same. Then here chlorination gives similar product. 1, 2, 3, 4, 5. Next, see that third one.